How does the Vernam cipher work? The Vernam cipher works by encrypting the plain text using a key. And the key here is the Vernam cipher uses mostly capital letters, and in this case we will use the key and the plain text, which has a length of about 3. So the key is the key and the plain text have to have the same length. So first what happens is it converts each of the characters in the plain text and the key to equivalent decimal. So here the decimal of S is 84 and A is 65 and T is 85. Now for B it's 66 and for O it's 80 and for B this is 66. Keep in mind this is the ASCII code for each of the characters. Now we convert the decimal to its binary equivalent. So 84 is 0101101. Now for A we have 65 which is 01000001. Now T, which we have 85, is 01011011. Now this is a binary for the plain text SAT. Now what about for Bob? Now we know that the decimal for B is 66, for O it's 80, for B it's 66. Now we convert these decimals into the binary code. So 66 is 01000010. O is 01010000. Again, 66 is 01000010. This is the binary equivalent of the key, which is Bob. Now all we have to do is we use the XOR operation. So basically that's the XOR gate. And another way of writing the XOR function is A and not B or not A and B. So basically A dot B dash plus A dash not dot B. Now applying the XOR operation, 0 and 0, 0 XOR 0 will be 0, 1 XOR 1 will be 0, 0 XOR 0 will be 0, 1 XOR 0 will be 1, 1 XOR 0 will be 1, 0 XOR 0 is 0, 1 XOR 1 is 0, and finally 0 XOR 0 is 0. Now we convert this binary into its decimal equivalent, which is 16 plus 8, which is equal to 24. So now we refer to the 24th letter, which is X. Next, we do this with A and O. So 1 XOR 1 is 1, 0 XOR 0 is 0, again 0, 0, 1, 0, 0, 0. So the decimal equivalent will be 16 plus 1, which equals 17. This will be the 17th alphabet, which is Q. Now we do the same thing for T and for B. So 1 XOR 1 will be 1, 1 XOR 0 will be 1, 1 XOR 1 will be 0, 0 XOR 0 will be 0, 1 XOR 0 will be 1, 1, 0, 0, 0. So the decimal equivalent will be 16 plus 8 plus 1, which will be 25. So the 25th letter is Y. So our encrypted text generated will be X, Q, and Y. So this is how the Vernam cipher works. Now say, what would happen if the key was sat, or if one of the characters was the same in the key, in the same position, say bat or sock. So in these examples, at least one of the characters are in the same position. Now all this does is, because if you apply the XOR operation, it'll be 0. So it just uses the same character. So example, if the plain text is sat and now the key is sat, the generated text, the generated encrypted text will be sat. Say if the encrypted text is B, we definitely know that the character at the second position will be A. However, we'd have to apply the XOR operation on S and B, and we also know that T and T result in T because the XOR operation will result in 0, and as we know that S and B is X, we know it's XAT. So this is how the Vernam cipher works. Thank you.